So we just talked about figures that are similar, have the same size, shape, but not necessarily the same size. I'm sorry. They have the same shape, not necessarily the same size. Okay. We said equals, the difference between equals, congruent, and similar, right? Notice that when we get to similar polygons, the angles have to be congruent. Sides do not have to be congruent. They just have to be proportional. Thank you, Xavier. We've just pretty much started, so you can have a seat. Yes, DJ. This is going to be your second to last question. Good one. Bad. Really bad. Did I already say that? Okay, here's what we call a similarity ratio. You only need to write that top sentence right there, okay? A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Then they give examples. We will talk about these examples throughout the class. Y'all gonna learn. Okay. This is getting into the side lengths, okay? The angles have to be the same, the side lengths have to be proportional. And we determine their proportionality based on what we call corresponding sides. We're going to talk about that word corresponding a lot. Corresponding means the same location on two different polygons. Notice, and I want to tell you the easy way to do it. You see when they named this triangle ABC, correct? They named it ABC. That means that AB has to be congruent to DE. I'm sorry, I said congruent. I'm going to mess you up. Has to be corresponding to DE. Okay? Those measurements have to be proportional to the other side length measurements. So, this was AB, DE. BC has to be proportional to EF, which it is, same proportion. And finally, AC has to be proportional to DF. Okay? And yes, I color coded that for a reason, right? Yes, I colored the order matters. As a matter of fact, that's the whole point. The order of all these figures matters. This is the last one. They have to be what we call proportional. We're going to work on proportionality. Okay, check this out. Not half, just proportional. Right? We'll talk about proportional. It means that it has the same ratio, okay? Which means that it would be equivalent in fraction or decimal form. All right, so check it out. Determine whether the polygons are similar. What makes them similar? Look at your definition. Somebody. Ratio. Similar ratio. No. Thank you. What makes polygons similar? Corresponding angles are congruent. Corresponding sides are proportional. Okay. If so, write the similarity ratio and the similarity statement. Okay. Now this is a little different. We're talking about AB, BC. ABC, CD, DA, right? And then over here, we're talking about EFGH. Okay. So when we say proportional, it means that it has to have that ratio factor. Okay. First off, oh yeah, it tells me it's a rectangle. What's true about rectangles, guys? Opposite sides are, say the C word, congruent. Okay, this would be 9. This would be 6. This would be 4. Okay, watch very carefully how I do this. Very carefully. I want to write my statement as this: AB over EF. Okay. Remember, we can break those up into line segments. Line segment AB over line segment EF. If this is a shape, I'll just say AB side AB over side EF. Right? Correct. What is the number? What numbers do we associate with that? AB is 6. EF is what? 6 over 4. Okay. Right? How about BC? What is BC? 9. And what was FG? 9, 6. Okay. Yes, sir. Like, will we ever make that? You're about to simplify these down. See, that's how we do this. Okay. Right. What about CD and DA? Help me out here. CD. 6 and what? 4. Okay. And then the last one, DA over HE. Okay. All right, now check all this out. If y'all want to, you can use your calculators. Fine with that. If not, what we're trying, you don't have to. Okay. I want the simplest form of these fractions. Okay. The simplest form of these fractions. Right? What's the what? 3 over 2. How about here? How about here? How about here? All right. So, yes or no? These side lengths are proportional. Yes. Okay. Are they congruent? These congruent, guys. 6 the same as 4. Okay. So they're not congruent, but are they proportional? Is the ratio of one side over the other side the same on all 4 sides? Yes, it is. That's what we've just done. Okay. Well, the whole point, we're gonna go for about 6 weeks of this entire. Yes, there is. Okay. So yes, is there a simpler way to do it? Sure. Okay. Soon we'll learn some proofs. Soon we'll learn some more theorems about similar polygons. Okay. But this is where we got to start. Okay. Because each problem we're going to start with this for now, and hopefully that'll convince you that it's worth it to learn some of these theorems. We can take maybe not shortcuts, but just math principles that will get us there quicker. Okay. Right. Yes. Here. Similar polygon. Okay. So what does congruent mean? Or identical. For now, you want to use the same, you can use the same. Okay. What does similar mean? But okay, same shape, different size, right? congruent meant same shape and size. Okay. Yes, sir. No. What was my question? Hey, what? So, if I write out, you just got a good question. Rectangle ABCD, what's my symbol for similarity? Okay. Remember this thing? It's similar to rectangle EFGH. Yes, ma'am. Okay. All right. Any other questions on that one? That's it right there. That's my similarity statement. You can put rectangles by the two. Say what? No, tell you what, you don't have to. Here is what I just did. Okay. That's what I just did in a nutshell. Right? We didn't even talk about the angles because we haven't talked about principles of rectangles yet. How many angles are there in a rectangle? And how many? What is the measure of each angle in a rectangle? Yeah, it's the same. But what is the measure? 90 degrees. Okay, 90 degrees. We talk about principles of polygons, but parallelograms a little bit later. Okay. DJ, see your similarity statement here? Okay, copy. To answer the question completely, that's what we would put. Similarity ratio is 3/2. Remember, that was my simplified ratio of each of those. Okay. And then you tell me the statement in a statement form. So here's my ratio, here's my statement. Okay. Hi guys. We're shifting gears a little bit. All right. All right, let's get down dilations and scale factors. Hopefully this will be a little bit easier because we just had our similarity talk. What is a dilation? Transformation changes the size of a figure, but not its shape. That sounds similar to another definition we just wrote down. Okay. We still are using. All right. So let me back up a second. What are the transformations you knew coming into class today? Rotation, translation. Very good. Okay. All we've done so far this year, correct? So now I'm going to add another transformation to your vocab, a dilation. Now, we're really going to test you on this. A rotation, a reflection, and a translation did not change the size of a shape. Yes or no? No. Yeah, the statement's correct. It did not change the size, correct? Remember what we call that? An isometry. Very good, okay? All right? So, here, remember isometry, we call it rigid transformation. It didn't change the shape. Here, I'm absolutely going to change the shape. I'm sorry, I'm absolutely going to change the size. Okay? All right? It's going to happen on a dilation. That's what a dilation does. It changes the size of a particular shape. Still using the terms pre-image and image. Okay? A scale factor tells me how much I'm going to either enlarge or reduce a figure. When I say enlarge, what does that mean? Good. When I say reduce, what does that mean? It's good. So at the end of every month, I get paid money. What happens to my bank account? It's bigger. And sometime within the first few days of that, we pay bills, and guess what happens? It gets smaller. Okay? You got me? Right? I don't tell you how much I got with the bank account. Right? This is the notation that you're going to see. Points A, B, and then you'll apply a scale factor by multiplying the scale factor by each coordinate point. Okay? Multiply your scale factor by each coordinate point. Right? today, I had you multiply 6 times 1/4, correct? So if I had a coordinate point that was at 6, we'll just call it 6, 6, right? 6, 6, and we dilated by 1/4, that would shrink down to 1.5, 1.5, right? See what I'm saying? Okay, let's flip that fraction. What if I had a coordinate point at 6, 6, and the scale factor was 4? What would my new coordinate point be? Scale factor is 4. Replace A with 4. Okay. A and B are both 6 and 6. If I multiply A times A and A times B, what is 24? 24, right? Okay. No math. It's okay. Right? Here we go. This is our guiding light for dilation. Anytime you get a scale factor that is greater than 1, your free image will enlarge. Anytime you get a scale factor that is less than 1, then it's going to reduce your image. Okay. Greater than, less than. Trick question. Let's see here. What if I have a scale factor that equals 1? What happens to my image? Or my free image? The free image and the image would be the same. Okay. Sometimes they ask that question, and I hate it. Right. But yeah, it would stay the same, correct? The coordinate point would change. Right? If I got this down, okay, I'll go for about 20 seconds. I do. Okay, we gotta move on. We gotta move on to get to our break. Okay, check out what happens here. Do not, guys, do not have to write this down. I'll go pretty fast to it, okay? All right, we're gonna put this into action now. Put this into action. It says I've got a border. Okay, so you put it in real life. You got some picture of a pony in your home, and you're like, I want to blow it up. And you call the frame guy and you say, you know what, man? I want to blow up my picture. I want to make it from 8.5 by 11 to 15, whatever. Okay, you got me? Right? And so one of the things you could do is you could put this as a dilation. You could say, I want each corner to expand, right? Correct? See what's going to happen? I want each particular of that frame, each corner is going to expand. All right? Now, here's a trick. If this is 0, 0, this is 0, 0, and it's multiplied by anything, where is it going to end up? 0, 0. So if you see any points at the origin, and you have a dilation, it should always still be at the origin in your image. Okay? You'll see that the more we do it. All right. What is my scale factor? 5/2. So I just told you, look for fractions. And what is this particular fraction? It's going to enlarge it, right? Correct? It's an improper fraction. It's going to enlarge it. Okay? Here would be our new coordinate points after we apply the scale factor. Right? It goes from 0, 0 to 0, 0, 0, 4 to 0, 10, 3, 4 to 7.5, 10. All we're doing there, okay, is we're taking each coordinate point and multiplying it by my scale factor. Right? All we're doing. And then I plot my new points. I got a nice big one. Okay? All right. That's all that happens. That's all we're we're going to do with evaluations. You're going to take that original, remember that original shape, we're changing the size. We're going to make it bigger, we're going to make it smaller. Okay? Got me? Nice. You can see here. Let me help you out here. Let's do this real quickly. This is A is at y'all write these down. A is at 0, 0. B is at 0, 4. C is at 3, 4. And D is at 3, 0. All right? Okay? We're going to work on this throughout the class. I'll make sure right now you understand the principle behind it. Okay? So, what will I do to each coordinate point? How will I make them smaller? By half. I'm multiplying each coordinate point by half. Hey, Bert, make sure you were paying attention. If I multiply 0 times a half, what do I get? If I multiply this 0 by half, what do I get? Good. So why was this one 1/2? It's magical, right? So A prime here is still going to be 0, 0, correct? Even. What's 0 times a half? What's 0 times a 4? I'm sorry, 2. What is 4 times a half? Good. Xavier, you're right. Xavier, what's 3 times a half? Close. What's 4 times a half? Okay. I'll do this one. D prime is 1.50. Okay. All I would do is then plot my new image. Correct? I plot my new image, and I'm good to go. Okay. Got me? Good to go. Yep. There we go. See that? You don't see that? You can see that. Okay. It's the same thing that I just did. All right? I promise. Right? And that's all we're doing with annihilation. Okay? Scale factor is key, obviously. Why is the scale factor key? Because it tells me everything that I do with annihilation. Right? It tells me if it gets bigger or smaller, and it tells me how much I'm multiplying towards 0.5. Okay? Everybody with me? I think we're going to do 2. We're not going to do that one today. Okay, sometimes we're going to get into this scenario. You know, I'm going to write this down right now. I'm going to go through it fairly fast. Remember, this is putting everything together. What does this question ask you to do? Yeah. So I want to make it very good here. Make it corresponding that I got to find the coordinates of U. Okay? All right? See that? It tells me that these two triangles, and I don't know if hard to see, TUO and RSO are similar. Okay? Similar triangles have corresponding angles that are congruent, corresponding sides that are proportional. Correct? Okay? This is where I got to put everything together. Okay? I will first start off writing down my corresponding sides as a proportion. This is why we got to start off this way. Okay? So they put it like this. They say R to O and T to O have to be proportional. And then they say OY and OU have to be proportional. We do a little cross multiplication there, correct? I'll remember this. Cross multiply. We'll get the probability and they'll actually the actual fractions up there, and you guys can start cross multiplying. I'll lose my mind. I'm gonna wait until December to get there, okay? Cut into your break a little bit here. All right? So there are times when I will do that as well. Okay? All right? I can cross multiply to find my scale factor. All they did was they took this length of 12 and set it over 9. They took this length of 16 and set it over x with a variable, right? Let's see this, correct? See what I'm doing there? We cross multiplied and solve for x to get x equals 12. Then, once we did that, we put that into a actual coordinate point and found a scale factor. What did I multiply by to go from 12 to 9, 16 to 12? Okay, you'd end up with 3/4. When we get to those today, I'm going to walk you through those. Okay, help you out a little bit more of them. I don't want to take too much of your break. Right. Any questions to begin with? We good? There's a lot today. I told you from the fire. Similarity, right? Similarity ratios, similar polygons, dilation, scale factor. Those are key throughout the day today.
Counselors.